Good evening, EE201. My name is Chris Sievers, and this is my final term project. I apologize in advance. The lighting situation isn't the greatest. It's impossible to see myself and the screen at the same time. So we're going to focus on the presentation for the time being. Thank you. So my presentation, or my final project, originally at the midterm I had proposed doing a locking mechanism. But you know, with the holidays and everything, and I had some Christmas lights sitting around, and I thought it would be a good application to try and put together a custom Christmas tree light timing, like a flashing light display controller. So I went with that instead. System description and specifications. So obviously we had a couple of components that were required to be used. The counter, a mux, D flip-flop, adder, subtractor. There were a bunch of different parts that we could use. I originally was thinking of trying to do the same thing with a D flip-flop and a counter, and basically count up myself having to flash the lights. But I thought it would be a better use, after doing some research online, of the device would work out a lot better if I could use a timer or have an oscillating signal. Originally I thought about using the MyDAC to produce that, but I thought it would be a lot nicer if I didn't have to plug my Christmas tree lights into my computer to get them to work. So I looked online, found a couple of things. This 555 timer could be used as my oscillation signal, and then I used that with a counter to count up and basically change the frequency at which the lights flash. I also wanted to have an on-off feature, and then I wanted to be able to change the flash frequency. Originally with a button I was hoping, but I could also modify the physical configuration of the timer unit itself to accomplish that. This was a diagram I found. Basic. I mean, I didn't, this isn't my exact, instead of the 12-bit counter here, I used the 4-bit counter that came in our lab package. So the first thing I had to do was get an oscillating signal using the 555 timer. So back in EE101, we had done a lab where we had a siren and a flashing light. So I knew, using the 555 timer, so I knew I had that. Unfortunately, it was still soldered to the practice board, so I had to unsolder it and then rewire it onto the breadboard. So that took a little doing there. I don't have any special unsoldering tools, just a regular soldering iron. And then of course this is the actual 555 timer, how I set it up, unlike on the previous page. Basically just a different size capacitor, which I found out later was going to be an issue. This is the overall design process. This is similar to the last project that we went through. Basically took the specs, went through, built the circuit, or determined the truth table and built the circuit, debugged the circuit, which is really the largest part of the whole process. So this was my final circuit as constructed. It was very simple. I ended up with just the 2 LEDs on here, although I did also get some Christmas lights that I planned on. You know, this is the controller that came with it. I was just going to cut it off there and attach that to my controller unit instead. So at the end, I could not get the lights to light up properly. I think it has to do with my 555 timer configuration. I didn't have the exact capacity that the circuit called for using 5 volts. So I had used a capacitor that I was using previously on a 9-volt battery, which I think is probably causing some of the issues. But so now I have a set of dead Christmas lights and a Christmas tree light controller that needs to be plugged into an oscillator on my computer to work. So obviously there's a couple of improvements that I could have made. I would like to be able to do it on an AC current, basically the same as what you get from a store. And you know, I could have wired it up so that I could run it just on the breadboard with the 9-volt battery, which I didn't actually test, but should work out pretty well. Then you'd have kind of portable Christmas lights, which would be kind of cool. So, all right, well, thank you, EE201. It's been a great semester. I hope everybody's doing well. Best wishes to everyone in the future. Thank you.